All right, good morning, guys. Let me do a quick visual and audio check. If you can see me and hear me, someone give me a thumbs up in the chat box. If you can hear me and see me, put a thumbs up in the chat box. Just want to make sure everything's working good. Okay, cool. All right, good morning to everybody here. Um, Going over Chapter 5 study guide today. And then tomorrow, you guys will need to complete your test. It'll be available come midnight tonight until midnight tomorrow night. You got 24 hours to take it. There will be a time limit on it, but it's not going to be a time limit that everyone should have plenty of time. I just put a time limit on it so you don't have it open all day long. That's kind of the goal and purpose behind all that. So, jumping into this study guide, or actually before we go to the study guide, anybody have questions over 5.6 homework? Anybody have questions over 5.6 homework? If you do, type those in the chat box. All right, Taylor says 5. All right, so let's look at 5. All right, first step with 5 is I'm going to write it as y equals the fifth root of negative x plus 3. Okay, write it as that. Now its inverse, the inverse of g of x would just flip your x and your y. Okay, so we'll get there to it. So x is equal to the fifth root of negative y plus 3. Okay, so we flipped x and y. Now in order to get this fifth root off, we got to raise both sides to the fifth power. So now I have x to the fifth is equal to the fifth root and the fifth power cancel, negative y plus 3. Then I need to subtract 3 from both sides in order to isolate that y because we want to get that y alone. So subtract 3 from both sides. That's x to the fifth minus 3 is equal to negative y. And then divide everything by negative 1 in order to get the y by itself. So that's negative x to the fifth plus 3, because a negative divided by negative is a positive, and then equals y. And then I'll write it as y equals negative x to the fifth plus 3. So if this is g of x, the inverse of g of x is equal to negative x to the fifth plus 3. Is that what, can someone confirm that that's the right answer there, negative x to the fifth? Or I guess I can look on the back, hold on. Negative x to the fifth, yeah, okay, cool. Negative x to the fifth plus 3. Okay, cool, yeah, very good. Now, this one, let me look at the graph there, because I think that's where it's getting a little funky at. Okay. Let's graph this one first. You're going to see this one. This one's going to be much easier, okay? So plus 3 goes up 3. And then x to the fifth would normally do this, right? And go up. But because it's a negative, it goes the other way. So just like x cubed, remember when x cubed would go up this, but when we did negative, it flips across the y-axis. So it goes like that. So same thing here, but this, instead of going like this, it's going to go the other way. So it's going to go down like this really fast, and then up like this. really fast. And I meant for that to keep going that way. Sorry. All right. I want to just confirm that. Okay, yeah, cool. We're cool there. All right. Okay, now this is what, if you're looking at the answer key and you're thinking like, man, this just does not look right to me. The reason that is because this negative right here. This negative right here is throwing it all off. Now, as I said while we're doing the notes, I'm completely fine if you guys wanted to graph this in your calculator to get the graph. All right, but if you are if you're wanting to understand it, okay, here's how this works. This right here, okay, there's something that we can do here that would make this look a lot different, okay? So notice over here on the back side, and I'm just going to go to this real quick. Notice that this 3 is over here to the right, and it's going like this right here, all right? Which is opposite of what it normally would do. It normally would go up and then out again, okay? But this negative right here kind of changes everything, okay? This negative right here is going to flip it across the y-axis, okay? So normally it would go, I'm going to kind of just makeshift this, like barely draw it. It would normally do this, right? But because this is a negative right here, okay, we are going to flip it across, okay? Or actually, excuse me, we flip it across, all right, and then it's going the other way. So your graph should look like this right here. I didn't know this one was on here. This is a little bit of a challenging one. So it should be looking something like that, okay? Did I draw that right? I did, yeah. Okay. That's a pretty tough one right there. I didn't know that one was on here, okay? That's a pretty tough one to graph. You're not going to have to worry about graphing it. And even if you did, you could use, I said you could use your calculator to kind of graph those. That's a challenging one to graph because it's on the inside, it's negative, it's doing some funky stuff. But as long as you got this right here, as long as you got the inverse, sorry, I don't know what's going on with the camera. I don't know why it's so blurry. There we go. As long as you know how to get the inverse, that's the main part. And then, again, if you didn't know how to like do the shortcut, you could always just make an XY table and punch in numbers there. Okay. All right. Sounds good. Any other questions on the homework? 5.6 homework. All right. Let's move forward to our study guide. Now, I'm going to tell you for the study guide, I'm going to work some of them. I'm going to probably work half of them. And then you need to work some of them as well, just so you're used to like doing it without me. You do have the answer sheet there on the back, so that will kind of help you in that. All right. So let's jump into this first one real quick. All right. Number 1, it says, or give me a thumbs up if you're with me. You got your study guide out. You're ready to go. Give me a thumbs up if you're with me. You got your study guide out and you're ready to go. Cool. Very good, Taylor. Thank you, Karen. Good, Chris. Good, Molly. Good, Jesse. You may need a piece of paper as well, just because I didn't give you too much space. So you may need a piece of paper to kind of work some of these through here. All right, so let's jump with number 1. It says write each expression in radical form. So this is what we started with 5.1. All right, we started with this right here. And it says write it in radical form. Your key part here, guys, is to know that your denominator will always be your index. Okay, so you put a 4 there. And then this right here is just going to be the inside, 10b. And you just write all of this, you put in parentheses, to whatever the numerator is, to the 7th power. Okay? Your denominator comes the index. Whatever's inside the parentheses comes here. And then your 7th power goes on the outside with parentheses around it. Okay? All right, looking at number 2. If you have a question, just type it in the chat box. Number 2, the square root. We know there's a square there. The square root of 10v all cubed. It says write each expression in exponential form. So exponential form takes it back to what it looks like up here. So I'm going to have to say 10v is what's here. I put it in parentheses. The index is 2, so that's our denominator. And then the outside is 3. So 10v to the 3 halves. Guys, note that this right here, 10v to the 3 halves, is not the same thing as this. These two are not equal, all right? Because it has to be the 3 halves is to the whole 10v, not just to the v. If you write it like this, the v it's just by itself, so that will not work. It has to be in parentheses and then raised to the 3 over 2 power. Okay? Looking at number 3. Okay? So number 3, there's not too much space there, so I'm going to get a blank piece of paper, and I'll kind of work it out. You feel free to do the same. All right, so number 3, 1,000 is equal to the quantity of 44 minus 2x raised to the 3 halves power. All right, so first step is to put that in radical form. Okay, so say 1,000 is equal to the square root of 44 minus 2x all to the 3rd power. So again, the 2 becomes the index, the 3 goes on the outside. Basically what we just did, guys, up here. So anytime you have something to a rational exponent, the denominator becomes the root, the index, and the numerator just goes on the outside. And that allows us to solve this problem now. So we just ask ourselves, what's the inverse operation of cubing? Well, the inverse operation of cubing is to cube root. So I'm going to cube root this side, and what I do to one side, I got to do to the other side. The cube root and the cube, not the square, but the cube root and the cube cancel, leaving me on this side the square root of 44 minus 2x. And then what times itself 3 times will give me 1,000? Well, 10. 10 times 10 is 100, times another 10 would be 1,000. So that's 1,000 there. Or no, my goodness, I said 10 and I wrote 1,000. That's 10 there, not 1,000. Okay. So then from there, I asked myself, all right, I need to get this x alone, so I got to take care of all this around it. So what's the inverse operation of square rooting? Well, it is to square. And what I do to one side, I got to do to the other side. The square root and the square cancel because they're inverse. 10 squared is 10 times 10, so that's 100, is equal to 44 minus 2x. From there, I subtract 44. 100 minus 44 is 56 equals negative 2x. Divide both sides by negative 2, and you get x is equal to negative 28. When you turn your study guide in, I want to see this work, okay? If I'm doing it, you need to be doing it. Okay? So x is equal to negative 28. Now, I want you to work 4 on your own sometime today, okay? Do it before tomorrow. Do it before your test. Or, I mean, I guess you could do it tomorrow and then take your test in the afternoon, whatever. So with this one, you want to start by subtracting 5 first. And then before you change your square roots, divide that negative on both sides to get it off of this side. And then obviously you'll just change the sign on that side. Okay? All right. So that's that. Number 5, the square root of 12 times the square root of 15. A couple different ways you could go about this. I'm going to use this paper right here. The square root of 12 times the square root of 15. What I'm going to do is just say the square root of 12 times 15. So anytime you're multiplying radicals, you just multiply the two insides. 12 times 15 is equal to 180. So the square root of 180. But now we need to simplify this and ask ourselves, which perfect square root, 4, 9, 16, 25, 36, which perfect square root goes into 180? Well, I know 4 does because the divisibility rule for 4 is if you can cut something in half twice and it's even, then 4 will go into it. But you just have to ask yourself, is there a bigger number? In this case, just if you went through there, you would actually get to 36. And the square root of 36, 36 times 5 is equal to 180. And then 100, and then the square root of 36 is 6 radical 5. So the answer to this right here is 6 radical 5. All right. That's number 5. Okay, again, multiply them. 12 times 15 is 180. Then you got to simplify this. What perfect square root? Now, if you wanted to go with 4, you could have done 4. So, like, if you would have said, well, how would I know it's 36? Well, you do have a calculator. But what you could say is, like, all right, let's go 4. 180 divided by 4 is equal to 45. Well, then that's 2. Radical 4 is 2. And then 45, 9 will go into that. So you'd have to say the square root of 9 times the square root of 5. And the square root of 9 is 3 radical 5. So that's 6 radical 5. So it's a different route to get there, but you still get the same answer. Okay? Still get the same exact answer. So it doesn't have to be the biggest, but if it is the biggest, it saves you a few steps. All right? That's that. Now I'm actually going to work number 6 with you. So let's look at number 6 real quick. So our first step with 6 is to distribute this. Okay, and when we distribute this, here's what happens. You say 2 radical 10 times negative 5 radical 6. So what you're going to do is multiply the 2 and the negative 5 and get negative 10. And then you multiply radical 10 times radical 6, which is radical 60. And then we add that to 2 radical 20. All right. Then here we need to simplify each one of these square roots. Simplify those down. So we got negative 10. And this right here would simplify to radical 4 and radical 15. Again, I'd have to ask myself what perfect square goes into that. 4, 9, 16. I know 4 will. 4 times 15 is that. So negative 10 times 2. And then radical 15, no perfect square root will go into that. So that's in simplest form. So we get negative 20 radical 15 there. Then on this side, we get 2 and then radical 4. And then radical 4, radical 5 would give me that. And that's 2 times radical 5, which is plus 4 radical 5. And that would be my final answer there. You good, Taylor? Okay, so that would be my final answer for 6. Negative 20 radical 15 plus 4 radical 5. All right. That's that one. I'm going to let you do 7 on your own. Okay. Keep in mind 7 is FOIL. First, outer, inner, last. First, outer, inner, last. FOIL. Okay. I'm going to let you do that on your own sometime. Now let's jump over here to this number 8. So number 8, I'm going to work on a piece of paper. So number 8, now we're dividing radicals here, guys. So when you're dividing, again, you could do this a couple different ways. I'm going to show you the way I'm going to do it real quick for you. So 3/5 times, or 3 radical 6 over 5 radical 50. Okay. So here's the way I would do it. I would actually do it by splitting this up. and saying times radical 6 over radical 50. Okay? And here's what I would do. I would then change that. Here's the rule it wants you to know, is that you can change that to the radical over 6 over 50. If the numerator and the denominator has a radical, then you can just write it as a fraction under a radical. And the cool thing about this right here is that you can simplify inside this radical just like it's a regular fraction. So I still have 3/5 over here times the radical, but here I would have 2 will go into both of those. 2 will go into that 3 times, and it will go into 50 25 times. So then from there, I could then take it back to individual square roots and say 3 over 5 times radical 3 over radical 25. So notice I started with individual square roots, but then I put them together, simplified them, and then put them back to separate, because now look that it's separate, I can now simplify this. So that'd be 3 over 5 times radical 3 over 5. And then once you multiply those denominators, you'd have 3 radical 3 over 25. And that would be your final answer. And that matches with the answer key. 3 radical 3 over 25. And guys, feel free to go back at any time, pause the video, check it out. You know, if I went a little too fast or anything, feel free to rewatch it, check it out, pause it, make sure you understand it. If you have any questions, email me at any time. That's number 8. Looking at number 9, 9 kind of snuck in there, I guess, because this right here, your issue here is you can't have a radical in the denominator, but technically speaking, you can simplify that denominator to just simply 5. And if you look at the answer key, that is the actual answer there. So number 9 is pretty simple, pretty easy. Now let me work number 10. 10 and 11 are where you have a denominator in the bottom, but it's not a monomial, it's a binomial. So you have to multiply by the complex conjugate. So I'm going to work number 10 on the paper. So number 10, my first step here, guys, is I got to get these radicals out of the denominator. Okay, got to get them out. So what I have to do is multiply this bottom by radical 5 plus 2 radical 3. And then I got to do the same thing to the top. Okay. So let's do the top real quick. 4 times radical 5 plus 2 radical 3. So when I distribute, here's what I'm going to get. 4 radical 5. You treat these like they're variables, guys, so it'd be like 4x, okay? You would just say 4x, but since it's a radical, you have to just say 4 radical 5. You can't say radical 20. That's only when there's 2 radicals. So 4 radical 5 plus 4 times 2 is 8 radical 3. And then we'll set that over here because that will be our numerator. Maybe not our final numerator because everything could simplify, but that came right here from this numerator problem. Now let's work the denominator problem. Radical 5 minus 2 radical 3 times 5, or radical 5 plus 2 radical 3. Now, once we FOIL this, we got to FOIL. It's a binomial times a binomial, so we FOIL first. Radical 5 times radical 5. Not sure if you all remember the shortcut, but anytime you have the same thing, well, that'd be radical 25, which is just 5. So anytime you have a radical times a radical, it's the same thing. It's just whatever's underneath there. So 5 is the first one. Move it over here. That would be 2 times, or plus 2 times radical 15. You can't multiply the 2 by the 5, but you can multiply radical. So radical 5 times radical 3 is radical 15, and the 2 just stays out there. And then minus this right here, the inside, negative 2 radical 15. And then the last would just simply be negative 4. Negative 2 times positive 2 is negative 4. And 3 times 3, radical 3 times radical 3 would just simply be 3 there. So negative 4. Negative 2 times 2 is negative 4. And then radical 3 times radical 3 is radical 9, which is 3. 2 radical 15 minus 2 radical 15, that's like saying 2x minus 2x, so that just cancels. And then I'm left with 5 minus 12, which is negative 7. So then I put that there in the denominator. I asked myself, can these three simplify, these three outside numbers? These two can, 4 and 8 can, by 4, but because the 7 can't, all three have to in order to simplify it. And since that's the case, our final answer would be 4 radical 5 plus 8 radical 3 all over negative 7 for number 10. All right, give me a thumbs up if you're still with me. This is making sense so far. Give me a thumbs up. All right, very good, Karen. Very good, Andy. Good, Adam. All right. So, I'm going to let you work 11, okay? Now, again, with 11, what you're going to have to do is multiply top and bottom by the complex conjugate, okay? And here you're going to be foiling twice. So you got to foil the denominators and foil the numerators, all right? Jumping down here to number 12, it says identify the domain and range of each, then sketch the graph, all right? Now, notice this is a square root function, so remember the square root function? The square root of x does this right here. It's just going out, all right? So, the minus 1 goes down 1, and the minus 2 on the inside goes right 2. So, down 1, right 2. So, again, minus 1 on the outside is a vertical translation, down 1. Negative 2 on the inside goes the opposite. It goes to the right 2. All right? Now, here you have to remember what the square root of x does. I don't know what's up with the camera today. Remember what the square root of x does. It goes right 1 and up 1. Then it goes right 4 and up 2. Right 9 and up 3. It does the opposite of x squared. That should make sense because they're inverse operations. So right 1, up 1. Right 4, 1, 2, 3, 4, up 2, 1, 2. And we're not going to be able to go right 9. And there's no negatives with square roots because then those would be imaginary numbers. So it should be looking something like this, guys. What? Okay, from here we got to do domain and range. So my domain, no values over here work because they're not a part of the graph. So we come right here to 2. So domain is 2, but we put a bracket on it because it's included. We'd put a parenthesis if it was like a hole there or something. So from 2 all the way to infinity. And then our range would be the up and down. So none of these are included, but -1 is included. So we say -1, comma, to infinity. And again, on your graph, with it being on canvas and multiple choice, you're not going to be able to you're not going to graph it, but you're probably going to have to answer one of these questions. Rock. Go lay down. All right. I got a question for you guys. Do you all understand domain and range now? Give me a thumbs up if you kind of understand domain and range. There for a long time, a lot of you all struggled with understanding domain and range. Are y'all good on domain and range now? Or some people like, yeah, I still don't fully understand it. All right, yeah, praise the Lord, Karen. Karen finally gets it. All right, cool, Adam. Cool, Andy. All right, let's go to the back side. Number 13. I'm going to let you do number 13 on your own, guys. I'm going to let you do number 13 on your own. But remember, go back in your notes and look at those, okay? Go back in your notes. Oh, goodness, Molly. That's scary. All right, so just to make sure you get a grasp on this, 1 through 3 is 5.1. 1 through 3 is 5.1. 5.2 is 5 through 11. 5.4 is 12. And 13 is 5.4? No, 5.3. Yeah, I skipped 3. Look at me, I can't even count. 5.3. One second, I gotta respond to this text message. Sorry. All right, sorry about that. So 5.2, I said 5.4 there, I meant 5.3. That's this graph up here is 5.3. So just trying to help you here. The next 14 through 17 is 5.4. This all is 5.5. 18 through 23, and 24 and 25 is from 5.6. Okay, just making sure you know where to go to look for notes. All right, so I'm going to let you do number 13. Number 14, 3 equals the square root of x minus 9. So I'm going to grab that piece of paper, and I'm going to work through that one here with you. So number 14, 3 equals the square root of x minus 9. So 3 equals the square root of x minus 9. So what we're going to do on both sides here is square. Because again, I got to isolate that x. So what's the inverse of square rooting? It is to square. And then I square this side, because what I do to this side, got to do to this side. 3 squared is 9. And the square root and the square cancel there, leaving me x minus 9. Then I add 9 to both sides. And I get x is equal to 18. Equals 18. Okay? I'm going to let you do 15. You got to square both sides. That's going to produce a quadratic over here. Again, go back in your notes. Go in your notes 5.4 to kind of see how we did those. 16 will be pretty similar to it. So 16 radical 6r minus 21 is equal to r minus 2. So in order to get that square off that r, that square root, I'm going to have to square both sides. What I do to one side, I got to do to the other one. The square root and square cancel there, giving me 6r minus 21. And then this over here, r minus 2 squared, goes to a binomial times a binomial. Then we FOIL this side first, and I'm just going to bring this right here down. First is r squared. Outside is negative 2r. Inside is negative 2r. And last is positive 4. So then I say 6r minus 21 is equal to r squared. Now I'm going to simplify those two to negative 4r plus 4. I then subtract 6r on both sides. And I'm going to go ahead and add 21. I know I'm doing 2 steps at a time. I know it's probably not good moving, but I think you guys are, can handle it. So that everything cancels on that side, leaving me 0 is equal to r squared minus 10r plus 25. Now, this tells me right here, and the reason why I combine like terms, put them over here, is because I knew I was going to have a quadratic equation. Okay? And how you solve quadratic equation is by factoring, guys. So we want to factor this. So 1 is my leading coefficient. 25 is my c. So what will multiply to be 25 but add to be negative 10? What multiplies to be positive 25 and adds to be negative 10? What two numbers? Somebody type it in the chat box. Good, Adam. Negative 5 and 5. Now, since the leading coefficient is 1, I can just write r minus 5, r minus 5. If the leading coefficient is not 1 here, guys, I'd have to factor by grouping. And then obviously when we set one of these equal to 0, we just simply say r equals 5. We don't have to say a multiplicity of 2. That only matters on a graph. Since we don't have a graph here, we just say r equals 5. Okay? That's number 16. I'm going to let you do number 17. Number 17 is very similar to number 16. So you got 15 and 17 on that section. Jumping down here to number 18. So this is where 5.5 notes, operation with functions. So it says f of n is equal to n cubed plus 3n. G of n is equal to negative 4n minus 2. And it says, say, f plus g of 3. So n cubed plus 3n. And then I'm going to say plus negative 4n minus 2. Now, I don't have to put parentheses around here because addition doesn't change anything. But if it's minus, like it is over here, I'm going to have to put parentheses around it. Okay? So, looking at this right here, at this point, since we're not solving it in terms of n, we're solving it in terms of 3. So plug 3 into all your n's. So that's 3 cubed plus 3 times 3 plus negative 4 times 3 minus 2. So that 3 times 3 times 3, well, 3 times 3 is 9. 9 times 3 is 27 plus 9 minus 12 minus 2. 27 plus 9 would be 36 because 27 plus 10 is 37. So 27 plus 9 is 36. 36 minus 12 would be 24. 24 minus 2 is 22. Okay? All right, let's look at number 20. All right, so same thing with 19, but what you want to be careful with, guys, with 19 is this. Make sure you say 4x minus 5 minus. You have to put this in parentheses, x squared plus 3x, and then make sure you distribute. Okay, now you work that one on your own. And then let's look in, if we're looking at number 20. So let's look at number 20 on this piece of paper right here. So 20 says g times f. So I'm going to say g and then times f. This is g of x. This is f of x. So we multiply the two. But fortunately here we don't have to FOIL. We could, but we don't have to because we're not solving it in terms of the variable. We're solving it in terms of 3. So I can just say 3 times 3 plus 2. And then negative 2 times 3 minus 4. So I just plug it in. Now I could FOIL and then plug the number in at the end, or I could just plug it in at the beginning, which is what I would encourage you to do. All right. From there, I get 9 plus 2 and negative 6 minus 4. Nine plus 2 is 11. Negative 6 minus 4 is negative 10. I get negative 110. All right. There we go. That's 20. All right. 20 is equal to negative 110. Now let's go down here with this one right here. Number 22. And this one over here is division, so it should be pretty straightforward, pretty simple for you guys. So let's look at number 22. It's saying f composed with g. So remember that means put g into f. Put g into f. So if f is 4n plus 2 and g is n squared minus 2m, it's saying take this and put it there. Put g into f. F composed with g of negative 1. We'll get to the negative 1 part here in a second. So we say 4 times n squared minus 2n plus 2. So here we say 4 times negative 1 squared minus 2 times negative 1. We plug negative 1 in. We don't have to distribute because we're looking for negative 1, so we just plug that in. And we say plus 2 there. That would lead us to 4 times negative 1 is positive 1. Negative 2 times negative 1 is positive 2. And then plus 2. That would be 4 times 3 plus 2, which is 12 plus 2, which is 14. So that would be equal to 14. You work 23. Okay, plug G into H. Now a thing about 23, guys, is what you want to pay attention to is that you're putting G into H. Make sure you put this right here, this 3x, into that x and that x. You got to put it in all x values. All right. Now, we had one like this on the homework, but we had to solve it in terms of x. And remember, it was a nightmare. But here you're solving it in terms of negative 1, so it shouldn't be that bad at all. All right. So you work 23. And then we're down to 5.6. And we'll just I'll work one of these. You can do the other one on your own. So I'm going to look at this one right here. F of n is equal to the 5th root of n minus 2. So that's like writing it as, y equals the 5th root of n minus 2. So the inverse, and look, I could write that n as an x. So I'm not trying to, so I don't want you to get confused or anything. So the n can be an x. And then you just switch them. X equals the 5th root of y minus 2. So in order to find the inverse, you switch the x and the y. In order to find an inverse, switch the x and y. You need to know that statement. What do you do to find an inverse? You switch the x and y coordinates. So then from there, we got to take the 5th root of both sides in order to get that 5th root off. Or we raise both sides to the 5th power. Then that's x to the 5th is equal to y minus 2. Because the 5th root and the 5 cancels, then we add 2 to both sides. We get x to the 5th plus 2 equals y. And I like to write it as y equals x to the 5th plus 2. So then the inverse of f of n is equal to, and I'm just going to write it with an n, to the 5th plus 2. That's your inverse. Now again, the graph is not as important, but because you're not going to have to do it on your test, but it's good knowledge for you to have. So plus 2, I'm going to do the bottom one first. Plus 2 goes up 2, and then n to the 5th is very similar to n to the 3rd. It's just much steeper. Okay? Then over here, negative 2 goes to it's on the inside, so it goes to the right 2. And then it does the same thing basically sideways. And again, if we made that y equals x line, we would see that it's a true reflection. It's the same thing on both sides, which is what a reflection is. Okay? So that right there would be my inverse. And then then my graph would be right there. I want you to work 25. Now, when you turn this study guide in, I want everything done. So I've left you 1, 2, 3, 4, 5, 6, 7, 8, 9. I've left you 10 problems. That's not enough for you to do this evening or after we get done with this, or for you to do tomorrow before you take your test as a good refresher. I want all 25 done when you turn it in. Okay, I want all 25 problems done to turn it in, and since I'm telling you it, I will remember it to make sure I look for it. All right. So just a quick reminder: you do at the school, your stuff is ready to go for next week. So you may want to stop by there in the next day or two, drop off everything you need, and here's that. It's there at the school. So you drop off here, guys. You pick up your new packet here. If you don't want to do that, you can send me one email of everything combined in one PDF. I'm getting a lot of like 5 different PDFs of 5 different homeworks. Hey, look, you just scan it, guys, and then scan the next one, then scan the next one, then hit save it all together, okay? And send me one PDF. Or you can drop it off, pick up the new one. If you do have a printer at home, you're able to print those just under canvases, under files and chapter, whatever it would be, okay? When did I say that this was due? Does anybody remember when I said this was due? Anybody remember when I said it was due? When do you need to turn it in to me by? Tuesday, good. I'm going to type it and say it. Tuesday, May 12th, by 4 o'clock. Well, happy birthday then on that day, Molly. So Tuesday, May 12th by 4, all Chapter 5 assignments are due. Okay? If you guys don't have any other question, that completes Chapter 5. I want you to do some on your own just so you get some more experience. Use your answer key to kind of guide your answer, and you will kind of go from there. Okay. Any other questions of me before we log off? Any other questions of me? If you are good, give me a thumbs up and you can be dismissed. You guys can go on about your day. Thanks so much for being here, guys. I appreciate you being here. Appreciate you paying attention. Appreciate your focus with my class. It means a lot to me, so I appreciate it. Look forward to see you guys on, what is today? Oh, no, today's your last week. So make sure you do your test tomorrow. Test tomorrow from, it's going to be open tonight at midnight to midnight tomorrow. So make sure you complete your test. Tomorrow, you have all day to do that. And then I won't see you guys again until next Monday. So make sure you stop by the school, pick up the packet, or print it off by Monday. And make sure you send me everything by Tuesday. You guys have a good day. Have a good one. I'll stay on here for a few minutes if you have any questions of me. Thanks.